And so we were left off with learning curves, and just to reiterate, not everybody learns at the same pace. The task I can do, the repetitive task a year from now, will be much faster, much more streamlined, fewer errors than I can do today. The concept behind learning curves. And here's an example of how that will taper off and reduce the amount of time used. So we want to do training, we want to do learning as a way, but there's a cost to that from a budgeting perspective. And you can see that over time I can produce more units based on that learning. The book goes through the calculation. It's interesting stuff, worth the read along the way. There are other factors, though, that you have to watch out for. There are times when you'll need escalation, and there are, and especially when it comes to management reserves, right? Remember those unknown unknowns for things you didn't see coming that now are a risk, right, to your project. Then also always eliminating waste. So the concept there is continuous process improvement, CPI, CI, continuous improvement. This is a quality standard in all project work. Every day getting better. It's the root of the issue behind the concept Kaizen. Okay? And then of course sometimes Murphy's Law. Stuff happens, right? We have to be prepared for that. That's why we get paid what we do, to manage those things. And sometimes we take care of it in contingency reserves or management reserves. Now, we can make better estimates, and we want the very best possible estimates, right? Projects are known for being over budget, right? So we underestimate. But with experience, we should have a risk register which should accommodate and account for risks in costs that we've seen over time. So that should get less and less. Now, there are a couple of types of errors for costing. One is just random. It's just random, right? And that's why I want people to write down the basis of their estimates. That's a term to know, the basis of your estimate. As a project manager, you should ask for that when you get the budget. And of course, make sure that that estimate also does not eliminates bias, right, along the way. Now, we want to account for risk, right? And we do that partly through contingency reserves. That is a way of reducing risk. Accommodating the known unknowns with a high probability and impact. Another way to reduce risk in your estimates is to use estimating tools like bottom-up estimating, which is very detailed estimating being added up. Another tool is PERT, Program Evaluation and Review Technique. It's a way to reduce the error, which means reduce the risk to your estimates along the way. So you can use tools like that and never ever pad. When you pad, you're adding risk to your project. You want good estimates and the basis of those estimates along the way. And so you'll go ahead and you'll apply risk analysis to your decisions. You'll look at the parameters and variables that you have about you, and you'll have a clear list of assumptions as well as constraints that give you a sense of the likelihood. You can even do, we talked about in risk management last week, qualitative analysis, right, where you create a matrix based on these variables and the parameters that you set. That would be a risk matrix using qualitative or quantitative analysis. And so you can estimate then risk profiles based on certain decisions you use. In fact, we have a whole course based on that, and it's called Deterministic Operations Research, right? Operations research, or deterministic research, right? We know there are variables, we know some things need to be determined, and we're going to look at ways to solve transportation and resourcing problems. That's for another course, but you would use those tools to eliminate or reduce risk, right? You can even do simulation, right? Monte Carlo is a famous simulator where you could take all of your project parameters, constraints, assumptions, activity, start and end dates, etc., the risks you've identified, put them all into a machine, and it will spit out the probability that your project will end on time. What's the probability that which path will be on your critical path of your schedule? Where are the biggest risks at? Those sort of things. And you can do all that through simulation techniques along the way. Okay. That is it for Chapter 7. Next, we're going to come back with Chapter 8. Okay.